All right. So as we continue moving forward, all right, we've encountered two different types of fish. There's three different classes, okay? And the first one are categorized as what? Just a very vague term. A hagfish and a lamprey are known as these types. They don't have any fins, don't really have any tails. They're scavengers and decomposers. Also known as knot fish because it's tough for them to grab a chunk of flesh, if you want to call it that, even from a dead animal, because of this characteristic. Say that again. Yeah, those are the jawless fish. Okay? Then we move forward to that of the skates, rays, and sharks, which are known as what type of fish, just in general? Starts with a C, because they're composed of this. Yeah, they're cartilaginous or cartilaginous fish. I was going to say you're going to hit yourself over the head when you hear this. Say, gosh, I knew that. Okay, and then finally we move on to the bony fish. But what is significant about respiration with these types of animals? Because where are they finding their prey items? It's usually what phylum that we're talking about, which was 2 chapters ago, which would be who? Yeah, so they feed on mollusks, and it's not that they're bottom feeders, but that's where we're going to find these animals. And what's a problem for any type of fish down there that's going to have sand and debris come into their mouth? It could possibly plug something. Yeah, their gill structures. So what we see happening is they've compensated for that, okay, because of these spiracles, okay? They prevent the clogging of the gills because these animals have to continue moving forward or else they actually drown. And what's the characteristics of all fish in water? Are they lighter or heavier? They're actually heavier than water. So, one of the things that the sharks do, they have a large liver with an oily compound in it. The jawless fish have osmotic equilibrium, and then moving forward to these, actually have a swim bladder. I don't know if we're going to get to that today, but this is the covering that covers those gills, and it's called this structure here. So as that flaps outwards, their mouth is open so water flows in and across the gills. So do we have anybody here, excuse me, that does freshwater fishing in the river? Any river? Yes? No? Okay. So if you don't have any water along, would you actually drink water from the river? You do that? Oh, okay. Well, you're thirsty. I think, I'm sorry, what's that? No, you're not on the verge of death. You have a canteen, but it's empty. You don't have any water bottles with you, and man, the fish are biting. You don't want to leave, but you're really thirsty. Okay. Okay. Well, you can do all that, but and I don't know if there's really any right answer to that, but one of the aspects I remember, this was years ago, still down in the prior school I taught at. It was in the springtime, and that's when I was still heavily into running, and didn't bring a water bottle along. And as we all know, in the springtime, it is very easy to get dehydrated. And so I think I actually did is went down to a stream where the water's current is running pretty fast. And I think that type of water's safe to drink. And I think in your case, if we're talking about a river, is it runoff from pesticides that you wouldn't drink, or it just looks like it's murky, or oh, could be that too. But I think if a person was thirsty enough, well then yes. But my point is, if you have this canteen, and if you take that canteen, take the lid off, and submerge that underneath the water, then the water does what? Just flows right in, correct? Okay. Until it fills up, then you pick it up and then start drinking. But my point is, what happens is, this is kind of like that canteen. Every time, okay, every time these fish open up their mouth and close it, and then open up this operculum where water flows out and it goes over the gills, that's how they grab that oxygen then. So it's like every time they open up their mouth like that canteen, water then flows in. So whether you call someone else, I would probably not drink it either, but I'm not out fishing a lot. Maybe should be. But, and if you had any secret fishing holes, you probably would not reveal that information, or would you share it? I'm not asking to say, oh gosh, where do you got to go fishing? But if you had a secret spot, do you share that amongst yourselves? Maybe amongst yourselves you would, but not with other people, especially outsiders. Are you not a fisherman anymore? No, I'm not either, so. But I'm sure if you ask nicely, say, yeah, you're going to want to go here and go fishing. Maybe, maybe not. But again, my point is, water, as it flows in across those gills, that's where that oxygen exchange is going to take place. Okay? And how many of you have picked up a big fish underneath their gills and feel that structure underneath there? That's not something I'm very familiar with, but it just looks like a whole bunch of like feathers, I think, as you open it up. And again, that just increases that surface area, like what we see here, an efficiency of drawing water across the gill surfaces to grab that oxygen. So in a lot of these fish, whether it's sharks or bony fish, why have these types of fins? If they're heavier than water, which they are, how's that going to help them as they're swimming through the water to go to the surface? Because they act as, what would you guess? So for these fins, it's going to generate something. What would that be to go to the surface? Yeah, they generate lift. That's right. So one of the things that we talk about, especially in that of birds, their wings are actually moving. Yeah, air, I get that, but there's also water vapor in the air. But that, whether it's considered as water or considered as air, if that has further to go over the top than the bottom, that's just going to naturally cause that concept of what you called lift. It's going to aid them in going up. Okay. Let's see here. get today. Okay, one more, and then I want to move to a different segment on a video to show. Now this wave motion, up and down, right? Or are we talking side to side? I think side to side like this. But one thing to think about, okay, yes, there's rapid metabolic oxidation of food, but do they need a lot of nutrients? Are they endothermic, do you think, or ectothermic? Because ectothermic means cold-blooded, endothermic means warm-blooded. So these fish, warm or cold-blooded? They're actually cold-blooded, so they are ectothermic. So even though they have a rapid oxidation of this food to absorb, they really don't need a whole lot because, again, their metabolic rates are not so high because they are, as we said, cold-blooded. So we see we're talking about diversity of these fish. We'll continue with that tomorrow. Then we'll start discussing tomorrow as well what you're looking for in that shark. We'll do that on Wednesday. Then we'll have those papers that we'll sign on Thursday. So, again, tomorrow we will pick up with this locomotion in the water. Okay, so we'll learn about tuna, which is a type of bony fish. We'll catch up to you next time.